All right, good morning, afternoon, evening, whenever you're watching this video. I was looking at my video from last year that I recorded on this lesson, and it's a good thing I did because it turned out that I tried to run this whole thing inside a PowerPoint and it was frozen on one slide the entire time. So that is not particularly beneficial. So I am re-recording the presentation using a screen recording. So you can probably see all the tabs that are open. That is what my brain is like. So I'm going to, hopefully this will go better. What I am in is the teacher side of Desmos, so you can see kind of what my tabs look like. And at the bottom, we have this preview button to preview it, and I'm going to run through the lesson that we'll be doing in class in this like preview mode just by recording my screen. So hopefully it'll go well and it won't be frozen on one slide the entire time. I don't even know if anybody last year said anything about that. Like, hey, Miss Taylor, your video was frozen on one slide the whole time. Anyway, so this video is going to walk you through the Desmos activity. We are doing a Desmos space lesson. So if you are making this up from home, what I would encourage you to do is to maybe pause for a second, and you want to have this video playing on maybe your phone or your laptop or something, or a tablet. And then you want to be on your laptop logged into Desmos. So the way it'll work in class is I will be projecting this up on the screen and you will be on your laptops going through the activity as I'm going through the activity. If you're doing it from home, then we'd like to mimic that as best as possible. So you might want to use your phone to play the video, play the lesson, and then have the activity up on your laptop. Desmos does not work particularly well on your phone. I know that from experience from piloting activities and like trying stuff out on my phone. So definitely you want to be on a tablet or on your laptop, something with a bigger surface for running the Desmos activity, and then you can play the video off of whatever is most convenient to play the video. So this lesson is on dividing polynomials, and this is where the area model really pays off. And there's a reason why we did multiplying with the area model and factoring with an area model. And it's because we know as teachers, we know that this skill is coming, and that the area model takes what is sometimes an impossible skill for Algebra 2 kids, like they just really struggle with it, and makes it something that a lot of students just say, well, this is really easy because I have this model that works really well. So this first slide is just a review of a multiplication with the area model. So we are going to multiply 2x minus 3 times 4x to the third plus 6x squared minus 2x minus 5. Just note that when you don't have like a mechanism of doing an exponent, the notational convention is to use this little caret to indicate what the exponent is, and that is located on the same key as the number 6. So you would do shift and then that, and sometimes it'll actually kick you over to an exponent, and sometimes it'll just display the caret. So all right, and so this is set up down here. Now, notice that you can change some things about this. So if I click on here, I got the pencil tool. I can have a line tool. If I click over here, you can change the color of ink that you're working in or the width of the line that you have. I guess I'll keep mine. I'll change mine to purple. I feel like purple today, and put it over here on the pencil tool. So you can kind of customize this a little bit. And we've done this before, and this is a good what's called a reteach or review if you weren't here to do the multiplication, or you just kind of struggle with the multiplication, so you can see it again. And if you think back to elementary school, you really need to learn multiplication pretty well before somebody taught you division. And the better you know multiplication, the easier division is. So looking at this, we multiply each of the individual boxes together, and then we'll add them up. So 2x times 4x to the third is, I don't know if I can use the touch screen. I can. Aha. 8x to the fourth. 2 times 6 is 12, and x times x squared is x to the third. 2 times negative 2 is negative 4, and x times x is x squared. And then 2 times negative 5 is negative 10, and that's a negative 10x. Negative 3 times 4 is negative 12, and that'll be x to the third. This will be negative 18x squared. Negative times a negative will give me a positive, so that'll be positive 6x. And then negative 3 times negative 5 is positive 15. And then when we go to write our final answer, we want to remember that we combine our like terms. And so our x cubes get combined with other x cubes. Our x squareds get combined with other x squareds. And our x's get combined with other x's. I don't know if it'll let me type that in there. So we would have 8x to the fourth. Oh, look at that. 12x to the third minus 12x to the third is 0x to the third. So you could type 0x to the third. That would be fine. But 0 times x to the third is just 0. So you can leave it out if you want to. And then negative 18 minus 4 is negative 22x squared. And then minus 4x plus 15. Okay, and so I opted to type that in. And again, you can leave out that plus 0x to the third if you want. So that's our review of multiplication. Hopefully I didn't make any mistakes in there. One could hope, although you never know. And that's our review of multiplication. Notice again, like the like terms on those diagonals, and that you want the like terms that have to add up to whatever you see up here. So if you have negative 18x squared and negative 4x squared, that would have to add up to negative 22x squared up there. All right. So, oh, there we go. There's our answer. Okay, so here's the completed table. Martha circled all the like terms in different colors. Good for Martha. She notices that the diagonal boxes always add together because they have the same exponent on the x. And the question there is, where did the green negative 22x squared term on the bottom come from? And so what I will give you guys time to do in class is click in that box and type something out. So if you're doing this from home, go ahead, type that in. I am able to see what you type in on my end. You saw my teacher dashboard a little bit earlier, so I can actually click on any slide and see what you typed in. So pause the video for a second. We'll pause it in class, and I want you to type in where the negative 22x squared came from. Okay. All right. Moving on. So now we've got an area model, doing another multiplication. So this is a practice problem. So what I would like you to do, and what we will do in class, is we will pause the Desmos. Like, I'll lock you guys in on a slide and have you guys fill this out. I can monitor what you guys are doing. I can display it on the screen, that sort of thing, make sure everybody is working. And then I'm just looking at that box down there. It looks like it was pasted in, kind of weird. All right, and so give it your best shot, and pause the video, and then unpause the video when you are done. Okay, so here's what I've got. So I've got 3x to the fourth. This is 6x to the third. 12x squared minus 3x, and then negative 2x to the third, negative 4x squared, negative 8x, and positive 2. And then we were asked to circle the like terms in different colors. We can go ahead and do that. And I'll use orange. Okay, and clicking my typing tool, I have 3x to the fourth plus 4x to the third plus 8x squared minus 11x plus 2. And even if that seems like a waste of time. Just trust me, it's not. We can never review and practice and make sure we're developing both our speed and our accuracy. If you're making mistakes, it's okay to make mistakes as long as you correct them and you note what that mistake is so that you can be better equipped to avoid it in the future. But again, I can look at any of these slides. I will probably spot check them. So I won't necessarily check every single slide on every single student because that's a lot. I will tell you exactly what things I will for sure check. But I might spot check a couple places just for some extra points or just for a completion grade or something. Make sure that you do have things written in on every single slide. Okay. So use your work from the previous slide to answer it. Can I even go back to the previous slide? Oh, I can. Good, because I'm not in a PowerPoint. So 3x to the fourth plus 4x to the third plus 8x squared minus 11x plus 2. You know, you really think that I would be better at doing this. 3x to the fourth plus 4x to the third plus 8x squared minus 11x plus 2 is D, right? You know, I can do this better if I had a piece of scrap paper. Plus minus plus. This one. Okay, great job. Oh, I guess that means I got it right. All right, go me. This is a day off, by the way, so I am recording this on a day off. All right, so great job. Move on to the next slide, explaining nothing. Okay, good. No explanation. Good to go. Okay, so now we're going to get into where are we heading with this. So this one is great. We have some fill in the missing boxes. So you've got some of the pieces on the top, some of the pieces in the center. You got some of the pieces down at the bottom filled in. It's beautifully color coded so that you have something to guide you. So what I want you to do is I would like you to pause the video and take about 3 or 4 minutes to fill in as much as you can. You will be allowed, you can erase, you have an eraser tool, but I want you to have something on your screen before I go over it, okay? And then if you need to go back and erase some stuff and make some corrections, that's gonna be 100% fine. But pause the video for about 3 or 4 minutes and work this out on your own. All right. So let's see what we've got here. So we're just going to kind of fill this in as we can go. So I have x, and then I have this 2x to the fourth, and then I have something up here. So x times something should give me this 2x to the fourth. That something would be 2x to the third. Okay, so x times 2x to the third. Now, from there, I can get this piece down here. Negative 4 times 2x to the third would be negative 8x to the third. Now, if you really got stuck on this, now that I've started it, pause the video again, give it a second shot. Okay, be perseverant, don't give up. Give it a second shot. Okay, and see what you can do with it from here. All right, for those of you that didn't need to pause it, you're like, no, go on. I have an answer. I am now going to come up here because I've got this filled down here as 12x squared. Negative 4 times what would give me positive 12x squared? That would be negative 3x squared. And once you write it in, slow yourself down and double check it. Negative 4 times negative 3 would give you positive 12, and then you'd have the x squared. From there, I can get this part. So x times negative 3x squared would give me negative 3x to the third. Moving over here, negative 2x times x would be negative 2x squared. Negative 2x times negative 4 would give me 8x. And all right, so let's fill in some stuff down at the bottom because this seems like it's coming up on a dead end, at least at the moment. So negative 8x plus negative 3x is negative 11. Sorry, that's x to the third. Didn't say it right. Negative 11x to the third. 12x squared minus 2x squared would be 10x squared. And now, now I've got my hint here. This needs to add up to 12x. I've got the 8x, which means this must be 4x. And now that I have the 4x, now I can say x times what would give me 4x. And negative 4 times positive 4 is negative 16. And so on that little purple blank down there, we would have negative 16. Oh, I doubled the negative there. They put the minus sign in for us. Here we go. Okay, so that's like our puzzle. Now, what happened there was almost polynomial division. The only thing that made it not quite polynomial division was the giving here of the negative 2x and the giving of the 12x squared. Other than that, that was pretty much a division problem. It just had a little bit of hints in there. I really like the use of the color. I have tons and tons of colored pencils in my room. So if the coloring helps you to like line your vision up with what you're supposed to be looking at in the different parts of the problem, then by all means ask to borrow a pack of colored pencils. All I ask is that you put the pencils back in the box and leave them neatly on your desk when you're done. That's the only thing I ask. Okay, next one. Oh gosh, that's yeah. Okay. So this one, it says fill in the table using the bottom answers and the colors to guide you. So this is what's called scaffolding in education. So we started with the multiplication, then we did like this kind of guided practice. Now we're removing a little bit of the supports, but we're going to keep the colors in there and see what you can do with it. So what we're doing is 6x to the third plus 7x squared minus 16x plus 10 divided by 2x plus 5. Okay, so that's what we're doing. Now here's how it works with the area model. There's my mouse. Okay, so this here is the area. This is what times what gives me the final polynomial. Okay, so this is the area. I know one of the things that got multiplied in. I'm looking for the other. Okay, so we're looking for the other. So with multiplication, we know the two outsides, the base and the height, and we multiply to get the area. In division, we know the area and one of the sides of the triangle, a rectangle, and we're looking for the other. So working this out, we know from experience using the area model that the 6x to the third is going to go in that upper left, and we know that positive 10 goes in the lower right, and they've got those nice colors there to help you see that. So the 6x to the third was colored in the red and they circled that box in the red. But again, if you've done a lot of multiplication with the area model, then that starts to become intuitive. You know that that is how the multiplication works when the multiplication is in order, which almost all the time it is, like with decreasing exponents. Now, here's where it gets like a little bit more interesting. These two orange pieces need to add up to 7x squared. Okay, so whatever's in here and here. So we need to kind of fill in the puzzle to see what we can get. Well, I know that this box here is 6x to the third, and I know that 2x is one of the factors. So what times 2x gives me 6x to the third? Well, that is 3x squared. Now that I know the 3x squared, I can find this box down here. This would be 15x squared. Okay, now we have to do some thinking. remember, this box plus this box have to give us 7x squared. So the question is 15 plus what gives me 7? And in this case, it would be a -8. I learned last year that a number line can help you tremendously with this. So if you know you need a 7 and you have a 15, if you picture like a number line, I think it'll let me do it. Okay, I'm going to erase this in a second. So we need a 7. We have a 15. How do I get from 15 down to 7? Well, I've got to go 8 to the left. And you can literally count it. If you got a number line, like count, I've got 15, but I need a 7. So count 8 to the left. So it would be -8x squared. Let me erase that because we don't actually want that there. All right, next one. Now we can fill in this top part. So 2x times what would give me -8x squared? That would be -4x. Double check it before moving on. -4x times 2x, -8x squared. Good. And now I can get this bottom one in the green here. So this would be -20x. And then again, a number line, okay, would be great. I am sitting down here at a -20, but what I need is -16, okay? So we need a -16. Those two boxes have to add up to a -16. So how do I get from where I am to where I want to go? Oh, well, I've got to move 4 places, but I got to move 4 places to the right. And so this would be 4x because you have where you're at and where you want to go. So we got to go to the right. And then I'll erase that again. Please do a number line. That made a huge difference for a lot of students last year. Just being able to see where the numbers were relative to each other. All right, so 2x times what would give me 4x? That would be 2, and then we could check it. That 2 times 5 is 10. Now, I do want you to be careful about filling in the 2 at the beginning. So you might look at that and say, oh, well, I know 5 times 2 will give me the 10. That will only work if it divides evenly. So here's my answer. My answer, remember what we're looking for, was the other side. So it would be 3x squared minus 4x plus 2. Go ahead and submit my answer. Okay. And again, remember, I can see what you're doing on your screens. So make sure that you are participating. If I decide to spot check and I decide, oh, I'm going to look at Sally's screen 6 and make sure she's got it filled in. Okay. So why would we ever want to divide polynomials? Excellent question. This was written by another teacher and then edited by a teacher at Atlantic Coast, and then I edited it further. So, but this is one of the original questions. Like, why do we want to do this? Rewrite, like, divide polynomials. Well, it can help us factor. It can help us with a couple other things that we can do with polynomials. So, it can help us to rewrite their equations in factored form. I don't know who they are. I guess there is we. I don't know. If you are given an equation in standard form, it is hard to see the x-intercepts. This is easy to do when the equation is in factored form. So polynomial division can be used to rewrite an equation from standard form to factored form. It can also be used to find things called oblique asymptotes, which is not an Algebra 2 topic, but it does come up in some future math classes, and it does do some pretty cool things. Plus, they look cool. I can show you one in class if you want. So this says, take a guess. What is one way we could write 6x to the third plus 7x squared minus 16x plus 10 in factored form? Well, if you look back, okay, this 6x to the third plus 7x squared minus 16x plus 10 is 2x plus 5 times 3x squared minus 4x plus 2. So, look at that. There it is. Okay, so why do we even care about dividing polynomials? Answer it honestly, I think for a lot of Algebra 2 students, you care about dividing it because it's going to be on a test. I mean, that's the honest answer to that. You're not particularly excited about finding x-intercepts. You care about finding x-intercepts because somebody's going to test you on it, and something that you got to know. And if that's your honest answer, that's your honest answer. But it does allow us to see features of polynomials, and if you trust that, we cover this for a reason, because there are fields and careers and jobs and real life stuff where this is critical, then you can answer like that as well. Just don't swear at me, okay? In your answer, don't do that. All right, Andre needs the exact x-intercepts of that function. When he uses his graphing calculator, or Desmos, he sees that there are 3 x-intercepts. So we can count them, 1, 2, 3. But only one of them is a whole number, okay? And so the question here is, what is the x-intercept that is the whole number? Well, that is not a whole number, and that's not a whole number. I think integer would have been a better word to use there. But this one is, and so the x-intercept that's a whole number is x is equal to 2. Is there another choice down there? Okay. So if the whole number x-intercept is x equals 2, if that is a root, then what's the factor? So this is tapping into one of those really important algebra ideas, that if you ended up with x is equal to 2, where did that come from in terms of a factor? So to answer that, we really want to think back to when we used factoring to solve quadratic equations. And if you got x minus 2 as one of your factors, you would say something like x minus 2 is equal to 0. So it says there, great job, ignore the text box. It has something to do with how the slide was put together, but just for clarity, this is what I might do in class. If you had x minus 2 as a factor, you would use the zero product property and say x minus 2 could be equal to 0. And then you would add the 0, or add 2 to both sides, giving you x is equal to 2. What we did there was we went backwards. We knew that x is equal to 2 was one of our x-intercepts, and we had to identify the x minus 2 as being one of the factors. So what Andre is going to do is he is going to divide by something that is a known factor. So he's going to take his polynomial that he needs the x-intercepts for, x to the third plus 2x squared minus 7x minus 2, and he's going to divide that by x minus 2. So that's the height of the rectangle. This is the area of the rectangle. And then we're going to figure out what the other factor is. What is the thing that is up at the top? So the directions there say do the division problem on a sheet of paper or on the area model I made for you at the left. Set it up like this, type your final answer. So I would like you to pause the video for about, I would say about 3 or 4 minutes to do this one problem. See what you can do with it. It shouldn't be taking you 15 minutes to do it. Start with what you know, what goes in that upper left-hand box, and fill it in one piece at a time. And then unpause the video. If you need to make corrections, that is fine to make corrections. Just make sure you're trying it on your own first. All right, so hopefully you did that. I'm going to use orange this time. So, oh, I got like a big orange dot there. Fantastic. Okay. So I know from experience, because I did all my homework on the area model, that x to the third is going to go in the upper left-hand box. And now I can start filling pieces in. So x times what gives me x to the third? Well, that is x squared. And then I can get this one down here. Negative 2 times x squared is negative 2x squared. Now I need to use my brain. I need these 2 boxes to add up to positive 2x squared. I've got a negative 2x squared. Remember what I said about the area model, or the number line here. I'm at negative 2. I need to be at positive 2. To get there, I am going to go 4 spaces to the right. And so this should be 4x squared. Okay. And now I repeat the process, but let me erase my little number line. So x times what gives me 4x squared? Well, that would be 4x. And 4x times negative 2 is negative 8x. Again, looking at what we got. Oh, I like the thinner one better. I need a negative 7. I'm at a negative 8. So here's negative 8. Here's negative 7. This is what I've got. This is where I want to go. I need to go 1 to the right. Therefore, this would be 1x. X times what gives me 1x? Well, that's 1. And 1 times negative 2 is negative 2. That divides evenly. Now, I am going to tell you, I mentioned it earlier, those numbers will not always match, okay? Yeah, so they will not always match, but if it divides evenly, they will. All right, so coming over here to type in my answer, remember that we are looking at the other factor. So what we are looking for is that there, x squared plus 4x plus 1. And you can click to share that with the class so you can see what everybody else did. We'll do that in class. Okay, on to the next. All right, so now we've got just another, this is like a practice one. Oh, but we got to notice something here. So on this one, we're going to take x to the 4th minus 6x to the 3rd plus 18x minus 4 and divide that by x minus 2. So this is the area. This is what we want everything to add up to. This is the height, and we're looking for the base. Now they give you a hint. Notice that there is no x squared. That means it is 0x squared. Just keep that in mind. Okay, pause the video for about 3 or 4 minutes. Try it on your own. Okay, try it on your own, then unpause it, and we'll talk through it together, and you make corrections as needed. Okay, so remember that the highest exponent always going to camp out in the upper left. And then we start filling it in. So x times what gives me x to the 4th? That would be x to the 3rd. Once I have that, then I can get this bottom one here. So negative 2 times x to the 3rd is negative 2x to the 3rd. These two together need to add up to negative 6x to the 3rd. I want a negative 6. I am at negative 2. How do I get from where I am to where I want to be? I need to go 4 units, and I need to go to the left, meaning this will be negative 4x to the 3rd. Repeating the process. Let me erase my number line. If you guys need to do little number lines all over the place, that's totally fine. X times what gives me negative 4x to the 3rd? Well, that would be negative 4x squared. And negative 4x squared times negative 2 is positive 8x squared. Those two boxes together need to add up to 0 because there is no x squared. So that means it's a 0x squared. Well, 8x squared plus what gives you 0? I hope we can do that. That is negative 8x squared. Okay, because those would cancel each other out. And then we repeat it again. X times what gives me negative 8x squared? Well, that would be negative 8x. And again, you can check your process all the way through here. Negative 8x times negative 2 is positive 16x. And once again, we have to figure out what will add up to positive 18. Now, I think because this is all positive, most of you are going to be okay. Like you would realize, okay, it's going to be 16 plus 2. So it'll be a 2x going on right there, but you can still use a number line for it if you want to, if you just want to see, how that works. So 16 and 18, we're sitting at 16. We need to get over to 18, which means we need to go 2 to the right. X times what gives me 2x? Well, that would be 2, and 2 times negative 2 is negative 4. And again, those bottom numbers there will not always match unless it divides evenly. So we will look at some that have remainders. Okay, and remember what we were looking for. So this is why directions are important. So we're actually looking for the other factor, which in this case is x to the third minus 4x squared minus 8x plus 2. If this seems easy, trust me, it usually is. All right, let's go ahead and share that with the class. Okay, and when you do that, depending on, as long as you're not one of the first 3 students, you'll see 3 other students' responses show up. Okay, so just another one. I want you to try to do this one on your own, and then we'll go over it together. So we are now in the phase where this is just like, now that you've seen how this works, see what you can do with it. All right, so pause the video, see what you can do with it. Okay, upper right-hand corner, x to the third. X times what gives me x to the third? X squared. Negative 3 times x squared is negative 3x squared. Oh, now this is interesting. What an interesting little twist. I have a 3x squared, negative 3x squared, and I want a negative 3x squared. So what goes in that position? Well, I don't need to add anything to it. So this would be 0x squared because we don't need anything in there. All right, so carry on. X times what gives me 0x squared? Well, probably 0x. Now 0x is just a 0, but like we're kind of getting at the idea of that bit of a placeholder in there. 0x times negative 3 is 0x. I need them to add up to 2x. I only have a 0x, so this would need to be 2x. And then x times what gives me 2x? And 2 times negative 3 is negative 6. Notice that it still works. Now, likely the 0 threw you off, okay? Because you're like, wait a minute, I got this column of zeros. But remember that math is consistent. So if you've got a good model, and the area model is a good model, it is a consistent, good model that's going to work for multiplying, it's going to work for factoring, and it's going to work for division. It's going to work all the time. You just kind of go through. Remember, 0 is just a number, okay? It might freak you out a little bit, but it is just a number. When you go to type your answer for this, you can type x squared plus 0x plus 2, but you do not need to type the plus 0x. You could just write x squared plus 2, and that would be fine as well. Click to share with the class. As long as you're not one of the first 3, you should see some other students' answers pop up. All right, now what about remainders? So this is what I was getting at before, where I said the number in that lower left, lower right box doesn't always match up. Okay, it just doesn't always match up. So let's see what happens if you try to divide 2x to the third plus 19x squared plus 31x plus 56 by x plus 5. So we start out with that 2x to the third, x times what gives me 2x to the third. So this is 2x squared. 2x squared times 5 is 10x squared. And then we need these two right here to add up to 19x. Again, when everything is positive, I think this part is easier. But when you end up needing a negative number, having negative numbers, please go to that number line. So 10x squared plus 9x squared would give you the 19x squared. X times what gives you 9x squared? That is 9x. 9x times 5 is 45x. Use a calculator if you're not sure. Okay, now that's getting a little bit big. We need a 31. So let's go picture it. So we've got 31. That is supposed to be a 31. And we're at 45. So we're sitting at 45. We want to go to 31. And so we're going to go left, like we need a negative something, and then you just need to find out how far that is. 45 minus 31 is what? 14. So 14x. X times what gives me negative 14x? Well, that would be negative 14. And now notice, so we're going to have negative 14 times 5, which is what? Negative 70. And notice that it doesn't match. Okay. 50 plus 20. Yeah. Okay. Negative 70. Now, what we do at this point varies. So this particular presentation is going to have you simply write like what the remainder is. I think that's what it does. You can tell like I bothered to go through the whole thing. I am going to have you write it as a fraction. Just going to have you write it as a fraction. So notice that it doesn't divide evenly. Here's how you figure out what you need. Imagine that there is another box like out here, kind of where I'm coloring, okay? What would need to go in that box to get it to come out to the right number? So you just kind of extend it out a little bit. Okay, so we are at a negative 70. Oh, it's going to be a big number. And we want a positive 56. Okay, so we got to go like a long ways to the right. That's going to be a big number. That is going to be positive 126. Okay, positive 126. And so you might say that the remainder is 126. I'm going to have you write it a different way. So just pay attention to what I have you do. Okay. So the problem is a little different. What did you get in the area model in that bottom right cell where we got the negative 70? Move on. There's nothing to explain. Okay. I think they don't say anything. Okay. I'm going to type in there what I want you to write. So let me go back to the answer. So we had 2x squared plus 9x minus 14. So 2x squared minus plus 9x minus 14. Why can I not remember stuff? Plus 9x minus 14. Okay. Now, what I want you guys to do, instead of writing like remainder 126, you're going to do a plus sign, and then you're going to give me a fraction. You're going to give me the number over the thing that you divided by, which in this case is x plus 5. Okay, so you're actually going to write it as a fraction. You're going to get me that number and then write it as a fraction. Make sure that you're making a note on there somewhere. Okay. In fact, if you're doing this from home, I want you to type that in so that I can see that you typed it in. Okay. So now we get to some challenge problems. Challenge 1, challenge 2. Let's do these two in class. So go ahead and pause the video and do challenge number 1. And then we'll go over it, and then we'll do challenge number 2, and then I'll give you what your actual assignment is going to be. All right, so for this first one, x times what gives me x to the third? That is x squared. This will be negative 2x squared. I need negative 4x squared. So on our number line, we need a negative 4, but we're at a negative 2. So we need to get from here down to here. That's going to be negative 2x squared. This will be negative 2x. Negative 2x times negative 2 is positive 4x. I need a positive 2, but I've got a positive 4. So you can do that on the number line, or you might recognize that'll be negative 2x. This will be negative 2, and negative 2 times negative 2 is positive 4. Now, I do want you to find that remainder. Like, what would that number out there have to be? Well, we want a positive 5, but we've got a positive 4, so we would need to get a 1 there. Okay, so what I would want you to type in for your answer is x squared minus 2x minus 2 plus 1 over, and then you're going to give me what you were dividing by, x minus 2. Okay, so I want you to write that as a fraction. Just saying that there is a remainder or just saying remainder 1 is not technically wrong, but it is not the most complete way for you to write your answer. Okay, so when you're writing an answer for me, this is how I want you to write it. I think in the practice problems, it's going to be a little bit different. So submit and explain. Explain your thinking. See, whoops. Cancel. See my amazing scratch work. It is a thing to behold, truly. Submit. All right. 16, challenge number 2. Do this one. So it's 2x to the third plus 4x squared. Notice that there's no x term or no linear term there. And so it could be a 0. And we're going to divide that by x plus 3. As we're going through this, do know that on most problems like that are not done in Desmos, you're going to need to be able to go from the written statement and set it up yourself. So if you think that that's going to be a real challenge, that's something to ask. But pause the video, try it out. All right, here's what I got. So 2x squared, 6x squared. I need that to be 4x squared, so that'll be negative 2x squared. This will be negative 2x. This will be negative 6x. I need it to add up to 0x, which means that's got to be positive 6x, which makes this a 6 and this an 18. Because your teacher is requiring you to find the remainder, I am at an 18, but I need a negative 5. So I need to get from here down to here, which means I need to move left 23 spaces. And so the answer that we're going to put in here is 2x squared minus 2x plus 6. And you can either do minus 23 over x plus 3, or you could do plus and then put the negative up in the numerator. Either one of those is totally fine. But that is how I want you to type your answer, okay? When you are writing answers for me, it's going to be a little bit different on the next slide. So submit and explain. Okay, this is how I spend my long weekend doing awesome math work. Just saying. Okay. All right, so that brings us to your practice ones. So these are set up similarly to the ones that we did for our factoring on the Desmos. So fill in the first factor with the divisor's terms. So you put that in, and then you're going to fill it in as you go. Okay. If you're doing this at home and you run into an issue, I'm going to click new problem. So I think you can pick, like different problems. So if you don't like the numbers, or you just want more practice, so we can go through this one. X minus 9. Okay, it tells me that's good. Fill in the blanks. Make a valid model here. So let's just see how this goes. Negative 9x squared. 81. I'm not digging that. 81x squared. Oh, but it's got to be 81x squared. Okay, well, that's good news. So 0x squared, which means this will be 0x. And this will be another 0x. Fantastic. This will need to be 1x, which makes that a 1, and that a negative 9. And because in this particular case, the negative 9 number here matched what I had, my remainder is 0. Okay, and then I can write out the quotient, which in this case is negative 9x squared plus 1. And will it... Okay. All right, so I wrote out the quotient. And then you can set it for a new problem, which is now marking wrong. That's hilarious. 8. There we go. Yeah, now it's telling me all my stuff in there is wrong. So you got to go back. That's inconvenient. So it's going to tell you everything's wrong. But you can set that to give yourself as much practice as you want, which is great. Clicking over here, okay, so practice 2, and then you have practice 3. They are just going to ask you for the remainder in here instead of writing it as a fraction. Just remember that when you're doing it for me, it should be in a fraction. So this video is a long one, not as long as the other one that I had. So it's still coming in at less than an hour. This lesson will probably take us more than one 90-minute class period because we're really going to go through this in detail in class. So if you watch the entire video, maybe send me an email, check in with me, and make sure that you can confirm what you need to have done before you come to the next class if you missed the first class on this, okay? But there you go. There is our lesson on polynomial division with the area model. And as you always, let me know if, when, whatever questions you have and what you want to go over, okay? And I will do everything I can to help you out.